So we see some strange expressions sometimes and different letters used for variables. So for example, this expression uses the variable f, and that could mean anything. In different fields of engineering and different fields of science, you might use different letters to mean different things. In this expression, we use the letter U. In some parts of mathematics, that refers to a speed. And in these expressions, we're using variables a and b, and we're also indicating multiplication here in some places, but you can see that there's no operator here to tell you what is happening between these two terms. Generally what that means, if there's no operator like a times sign, there is in fact a times sign here. And the reason we leave it out is because it makes the whole expression just a bit neater. Okay, so that means that all of these terms are multiplied by together. Let's just put those times back in here again. Okay, so we're going to look at a couple of things to simplify our expressions. One technique is collecting like terms, and another technique is factorizing. And then while we're doing that, we're also going to review index laws and what we do with these exponents or indices above and below a dividing line here. So generally, when you're given an expression like this, your job will be to make it simpler. And one way to do that is to collect the like terms. And we've got two types of terms in this. We've got terms that involve f and terms that don't involve f. We might have a more complicated expression where other variables are used as well. But let's just focus on this one for now. The important thing to remember is the order of operations. So for example, we need to do our brackets first, and then we need to do our multiplication and division. And this here, as we said before, this here means a multiplication, 3 times everything in the brackets there. And then we can take care of, after that, we can take care of our pluses and minuses. Okay, so I think the first thing that we should do is expand everything out. And that initially will make it look a bit messier, but that will allow us to collect this f here with that f there. And that's what we're actually trying to do. So let's times everything out. 3 times this plus, or 3 times this minus 3 times that. So that'll be 3 times 8, which is 24f. Yeah, 3 times 4 is 12, but it's a minus 12. Okay, that takes care of all the brackets, so that's fine. And then just to make it easier for ourselves, I think let's just not make any other changes for now. Just copying those two terms down. Step through your problem in small steps. That allows you to go back and check for mistakes. Okay, so now we collect like terms. This is an f and this is an f. So let's put those together and we'll write them all out again. 24f, sorry. 24f, and it's a plus 6f. Okay, and this is a minus 12, and this is a minus 3. And it's worth sometimes thinking about this as a term with a minus sign, and this is also a term with a minus sign. So that allows you to move the term, the 12 and the minus sign together. The same over here. So we keep everything organized, and then we are less likely to make a mistake. Okay, so minus 12, minus 3. Okay, so is that a minus 9 or is that a minus 15? I'll let you think about that for a moment while I work out this one here. Let's just write this a little bit more neatly. Okay, so 24f plus 6f, that's okay, that's 30f. Okay, now let's work out what this is about. Minus 12 minus 3, is that minus 9 or is that minus 15? So you can think about minus numbers as you walking backwards and plus numbers as you walking forward. If you walk back 12 steps and then you walk back another 3 steps, how many steps was that backwards? Obviously, it's minus 15. So it's really important for you to keep track of your minus signs here. So it's not that one, it's minus 15. Okay, so we can bring these two terms together now, and that expression simplifies to 30f minus 15. Okay, now we can leave this expression as it is, or we can make it even simpler using a process called factorizing. And let's just look at these two examples here and then we'll come back to this one. So here we have an expression, 30u minus 12. Factorizing is trying to make the numbers as small as possible. And so we're looking for what we can divide into these two numbers to make them as small as possible, but it's the same number so that we can take it outside the brackets. So what we want to do is something like this, something times u minus something, okay, and then we have a something out the front there. The idea is that we divide this number by something and the same here, and then we bring that outside the brackets. So let's see now, this is an even number, that's an even number, so we could divide by 2. That would be 15 and 6. But if we did that, can we do any better? Maybe what we can do, can we divide by 12? 12, we can certainly divide by 12 there, but not there. Okay. What about 6? Can we divide by 6? 6 into that would be 2, 6 into that would be 5. Yeah, 2 and 5. 2 is a prime number, 5 is a prime number. That's about as low as we can go. So if we brought the 6 out like that, okay, so let's try it and see, and then we can check. So 30 divided by 6 is 5. 12 divided by 6 is 2. Let's check our maths by expanding it again. 6 times 5 is 30. Yes, that's right. 6 times minus 2 is minus 12. Yeah, that's right. So our factorized expression is that. 6 outside the brackets, 5u minus 2. And for some applications, this is the most efficient way of expressing it. And for other applications, this is the most efficient way of expressing it. Factorizing, when you're asked to factorize, what you want to do is make these numbers as small as possible. Let's try that for this one here. So we can divide, let's see. Oh, you know what? We can divide by 15, both of these. What would that give us? Okay, so 15 divided by 15 is 1, but there's a minus sign there. 30 divided by 15 is 2, so that'll be 2f, okay, and brackets there. And what did we divide by? 15. Okay, so let's check that. 15 times 2 is 30, 30f. 15 times minus 1 is minus 15. So that's how we would factorize that. Now let's have a look at this one. This one has indices, so we might need to review our index laws here. Before we do that, let's revise our index laws.